Linux file permissions can seem confusing. There's all these different commands you need to use to inspect and adjust them, and then there's all these different fields. How does it work? What does it do? We're going to take a look at Linux permissions, what they do, how to inspect them, and how to adjust them in a smart way. Let's jump on in. All right, so the first thing we need to do when we're working with permissions is we need to know what we have. So to look at your file's permissions, use a listing command, an ls command. But not just any ls command, you want to add on the -l option for a long listing. And the long listing is going to have a first field in front of every single file in the listing that has all of your permission data in it. It's actually a 10-character field where the first character indicates the type of file. Not related at all to permissions. Well, maybe it is. So that first field in our output here, you can see that there's one directory, and that's noted by that very first field being a D for directory. The other files just have a dash, meaning they're a regular file. There are some other types as well, but we're not going to get into them today. What we want to look at, though, for permissions is those next 9 fields. So the next 9 fields are broken down into 3 subfields. In fact, it's the same 3 permissions that repeat 3 times. The first subfield is the user owner permissions. And there are 3 possible permissions that you can grant to someone on a file or directory. Read, meaning they can look at the contents of the file or directory. Write, meaning they can make changes to the contents of the file or directory. Or execute, which for file means you can run it like a command, or for a directory that you can access the directory in order to get at the files that are within the directory. So we can see on this file that I'm highlighting that for the user field permissions, we have read permission. I can look at the contents of this file. Write permission. I can edit and make changes to the stuff that's stored in this file. And the third field is a minus, which means that there is no execute permission that could be there, but on this file, it's turned off. If we look up one line in the output, you can see that for the directory, all 3 permissions are present for the user. The person can look at the contents of the directory, they can add and remove files from the directory, they can write to it, and then the execute permission is also present, meaning that someone can access the directory to get into those files and stuff that's underneath of it. All right, the second set of 3 permissions, that applies to the group that owns this file. And it's the same 3 permissions again. Read permission, write permission, execute permission. What do you allow to the group of people that own this file? And this is where we need to look a little bit further in the long listing output. You'll see a little bit further down the line, there is 2 names listed there. So the first one is the user owner of this file, and that's who gets the permissions that we just talked about as the first field of permissions. The second owner, that's the group owner. Now on Red Hat flavored distros, every user is a member of their own private group that shares their name. So that's why you see the same name twice on your long listing line, is because it's the user owner and their private group that's the group owner. But that may not be the case for every file. All right, so returning back to our permission string, that second set of permissions is what we're offering to the group that owns this file. And on the file I have highlighted, we're offering read permission. The person in the RHEL group can look at the contents of this file, but they're not allowed to make changes to it because they lack the write permission, and they're not allowed to run it like a command because they lack the execute permission. If we look up one line and we inspect that same field in the directory, the RHEL group, who's the group owner of this directory, can read the directory. They can look at the contents of the directory. They do not have write permission, so they can't add any new files or remove files from this directory. But they do have execute permission, which allows them to cd into the directory and access the files and stuff that's stored in the directory. All right, the last field of permissions. There's a couple different names that you'll see around online for this last field. I like to describe it as others. All right, people who are not the owner of the file or directory, and people who are not in the group that owns the file or directory. These are the other people on the system that may be bumping into this file or directory. You may also hear people describe this field as the world permissions, but I don't like that because world implies everyone, but it's not everyone. It's everyone who's not the owner of the file or in the group that owns the file. So I like to use others because it allows me to keep this mutual exclusivity of these three distinct sets of people and what their permissions are. All right, so we can see in this highlighted section for others for this file, they have read permission, but not write and not execute. So let's do something really terrible. We're going to change the permissions on this file, and we're going to give everyone all permissions. And I see this often out there in the world. So you're having permission problems. You don't really understand permissions. The default is to just turn everything on. A horrible, horrible idea. But we're going to do it anyway because why not? All right, when you're adjusting permissions, you want to use a command called chmod, or chmod, or chmod. I've heard it described a couple different ways, but it's really to change the mode of the file, or changing the permissions, the mode of the file. And then you have to describe what it is that you want to change about the permissions. And so when you read forums and whatnot, there's probably something that says, oh, just chmod 777. And the name of the file. All right, now when we do our long listing, we can see that our file that we added all permissions to, that's reflected in the output. The user owner has read, write, and execute, the group owner has read, write, and execute, and others also have read, write, and execute. Now, why this is a terrible idea. You're now granting anyone on the system who happens to bump into this file the ability to look at its contents, make changes to its contents, or in the case of this file, run it as though it's a command, which may or may not make sense. So when you're working with permissions, you want to understand what the permissions do, and then grant the needed permissions to the intended audience. Right? So if you're having permission denied problems, but it's only affecting you, then add permissions for yourself that then allow you to do what you want with that system. All right, so we're going to toggle back our permissions from this file. We're going to use chmod, and the default permissions that were on it before were 644. All right, now I'm throwing out a 3-digit number, and I'm just like making it up, right? No, the numbers mean something. And so it turns out that for each of these three people, users, groups, and others, each one has their permissions described by one of the 3 digits I'm using. So when I chmoded our file to 644, that first digit, 6, described the user owner's permissions. The second digit, 4, described the group owner's permissions. And the third digit, 4, described the others' permissions. So when we're changing permissions in this way, we're always specifying at least a 3-digit number to describe user, group, and other permissions. But how do we arrive at the values? Why is it a 6 and not a 4, or a 7 and not a 4? So that depends on what permissions you're looking to grant. Each of the permissions has an octal value. And I won't bore you with all the binary math, but essentially, each of the permissions has some value that goes with it. So execute permission is worth 1, and write permission is worth 2. So if you want both write and execute, that's 2 plus 1, 3. If you want read, which is worth 4, and write, which is worth 2, that's a total value of 6. And so that's how we get to these actual values that go into each of these 3 digits that we're sending to the chmod command. So when I look at chmod 644, what I'm saying is I want read and write for the owner, read only for the group owner, and read only for others on the system. So if I look at a long listing, after changing the mode of the file, that's what I see expressed in that first field on this line for the long listing. I see that the owner of the file has read and write, the group has read only, and others have read only. All right, so I have another file down here that's a shell script. And if I try to run it, and I specified that in my current directory, there's a file called hello-world.sh, and I try to hit enter, it says permission denied. Right? Because to run a file as though it's a command, that file needs the execute permission enabled. And we can see from this long listing that the user that owns the file, which is the user I'm logged in as, has read and write permissions, but does not have execute. So if I wanted to add execute permission to this file so that the user can run it like a command, I'm going to have to use the chmod command again. All right, but now that first field of the permissions, I want read, write, and execute. 4 plus 2 plus 1 for a total of 7 as my first character. And then the others I'm going to keep the same. Each one beyond that has read only, which is 4. So when I chmod 744, I'm saying the user owner should get all permissions enabled, the group owner read only, others read only. And we're going to inspect that with a long listing as well. So looking at the long listing, we can see that the user owner has read, write, and execute, the group owner has read only, others read only. And now when I run that same command of /hello-world.sh, I don't see that permission denied error anymore. Instead, it executes the instructions in that file as though it's a command and prints hello world for me. So that's a little bit on setting permissions and explaining how we get to the values that we're passing to the chmod command, as well as inspecting the permissions with long listings. Did you know that you have write permission to this video? Yeah, mash that like, share it with a friend, leave me a comment. We'll read them because we have read permission.